Hello student, in this lecture I will discuss the instrumentation of IR spectroscopy. So this figure represents IR spectrometer. Okay, so what are the component have in the IR spectrometer? Okay, so here I will discuss the details of various part of infrared spectrometer or IR spectrometer. Okay, so let's start our discussion. So see here, first part of IR instrument is radiation source. So this is our radiation source. Okay. So first part of IR instrument is radiation source. It may be Nernst glower. Okay. Or so first part of IR instrument is radiation source. So there are various types of radiation source we can use in IR spectrometer. So sources may be Nernst glower or global, okay, or mercury arc or tungsten filament or carbon dioxide laser source. Okay, so it may be different. So we can use different types of source. Okay, so first part of IR instrument is radiation source. Okay, so it may be Nernst glower, global, nichromolar, okay, or carbon dioxide laser. Okay, and this source, that means radiation sources, are electrically heated from 1200 to 2000 degrees Celsius to produce IR radiation. Okay, so first part of IR instrument is radiation source. There are different type of radiation source we can use in IR spectrometer. So sources may be Nernst glower, global, nichromolar on a ceramic support or carbon dioxide laser. Okay, and these sources are electrically heated from 1200 to 2000 degrees centigrade to produce IR radiation. Okay, next part are mirror M1, that means next part are this mirror M1 and this mirror M1 dash. Okay, and this mirror are used to reflect the IR radiation towards the reference and sample. This is our reference cell and this is our sample cell. Okay, so first part of IR instrument is radiation source. Radiation source may be Nernst glower, global, nichromolar on a ceramic support or carbon dioxide laser. Okay, this radiation source are electrically heated from 1200 to 2000 degrees Celsius to produce IR radiation. Next part of this instrument is mirror M1 and mirror M1 dash to reflect the IR radiation towards the reference cell and sample cell. Reference cell generally contains KBr because it is transparent throughout the IR ranges. Okay. So reference holder cell generally contains KBr because it is transparent throughout the IR ranges. Now coming to the sample holder, which contain sample to be analyzed. Okay, now next part of this instrument is beam chopper, that means this. Okay, this is beam chopper. Okay, so next part of this instrument is beam chopper, which is operated by a motor and alternatively sends radiation from reference cell and sample cell respectively towards the mirror M2 dash. Okay, so I will repeat again. So first part of IR instrument is radiation source. Radiation sources are electrically heated from 1200 to 2000 degrees Celsius to produce IR radiation. Next part of this instrument is mirror M1 and M1 dash. This is used to reflect the IR radiation towards the reference cell and sample cell. Reference holder cell generally contains KBr because it is transparent throughout the IR ranges. And sample holder cell contain the sample which we want to be analyzed. Okay. And next is beam chopper. And this beam chopper is operated by a motor, and this chopper alternatively sends radiation from reference cell and sample cell respectively towards the mirror M2 and M2 dash. And finally the mirror M3 dash, that is the mirror M3 dash. Okay. Next part is slit S1. This is our slit S1. Next part is slit S1, and then coming to the diffraction grating, that is our, let me clear all this thing. This is our diffraction grating. So after slit S1, there is diffraction grating, and this diffraction grating is used to improve the resolution of IR spectrum. Okay. After diffraction grating in IR instrument there is slit 2. This is second slit 2, and then there is one detector. Okay. So see, in IR instrument different type of or various types of detector may be used. Okay, and this detector may be, so in IR instrument various types of detector use, and this detector may be bolometers, thermocouple and thermopile, pyroelectric detector, Gole cell, etc. Okay. And next part of this instrument is amplifier. This is our amplifier. Okay, after detector there is amplifier, and this amplifier is used to amplify the signal. Okay, and last part is recorder. This is our recorder. Okay, recorder. Okay, so here I have discussed all the part of IR instrument. Okay, so now coming to the working of IR spectrometer. Okay, so let me clear all this thing. Okay, now see the working of IR instrument. Okay, so first we will short on the radiation source, and due to electrical heating it will produce IR radiation. Okay, so first we will on the radiation source, and due to electrical heating it will produce IR radiation. This radiation will go towards the mirror M1, which reflects half of the radiation towards mirror M1 and half of the radiation towards mirror M1 dash. Okay, so first switch on the radiation source, and due to electrical heating it will produce IR radiation. Okay, and this IR radiation will go towards the mirror M1. Okay, and which reflects half of the radiation to this mirror and half of the radiation to this mirror. Okay, now see mirror M1. Now M1 will reflect the radiation towards the reference cell, and radiation will pass from the reference material KBr without decreasing in the intensity of IR radiation. Okay, so first we short on the radiation source, and due to electrical heating it will produce IR radiation, and this radiation will go towards the mirror this, and this mirror will reflect half of the radiation towards the mirror M1 and towards the mirror M1 dash. Okay, now consider the mirror M1 first. So now M1 will reflect the radiation towards the reference cell. M1 reflects the radiation towards the reference cell, and radiation will pass from the reference material. Here reference material is KBr, so radiation will pass from the reference material KBr without decreasing in the intensity of IR radiation. Okay. At the same time, mirror M1 dash, that means this mirror, will reflect the radiation towards the sample cell, and some radiation will pass from the sample and some radiation will be absorbed by the sample. Okay, so intensity of the passed radiation will be decreased when the radiation, and now when the radiation reach to the beam chopper, it will alternatively sends the reference and sample radiation towards the mirror M2 and M2 dash. Okay, and finally M3 dash. Okay, so when the radiation reach to the chopper after reference and sample cell, okay, chopper alternatively sends the reference and sample radiation towards the mirror M2 and M2 dash, and finally M3 dash. Finally mirror M3 dash. Okay, so first taking the reference radiation for explanation. Okay, now see this mirror, that means mirror M2 will reflect the respective radiation. Now first we take reference radiation for explanation. So this mirror, that means mirror M3, will reflect the respective radiation towards the slit S1. Here there is slit. Okay, so mirror M3 reflect the reference radiation to slit S1, then it goes to the diffraction grating. Grating will diffract the radiation, so resolution will be improved, and this diffracted radiation will be passed through slit S2. Okay, so mirror M3 reflect the respective radiation towards slit S1, and then it goes to the diffraction grating. Grating will diffract the radiation, so resolution will be improved, and this diffracted radiation will be passed through slit S2. Slit S2 will allow the radiation only in the range of 4000 to 400 per centimeter. This is IR range. Okay, so slit S2 will allow the radiation only in the range of IR region, that means 4000 to 400 per centimeter. This reference radiation will reach to the detector, and the detector will analyze the intensity of the radiation. Okay, now chopper will send the sample radiation. In that time, reference radiation will not reach to the detector. Okay, so sample radiation also follow the same step, and it will reach to the detector, and this alternate process will continue throughout the analysis. Finally, detector determines which frequencies has been absorbed by the sample and which are unaffected. So finally, detector determines which frequency has been absorbed by the sample and which are unaffected, that means which are transmitted. Intensity of the absorbed radiation will be decreased, and signal will be amplified, and lastly signal will be amplified by the amplifier, and finally IR spectrum will be visible in the recorder. Okay, and in IR spectroscopy, in the recorder, spectrum will be appear in terms of percentage of transmittivity versus wave number. Okay, so this is the working principle of IR spectrometer. Okay, in the next lecture I will elaborately discuss each part of the instrumentation of IR spectroscopy. Okay, which type of source we can use, which type of detector we can use, which type of reference cell we can use, reference material we can use. Okay, so in the next lecture I will discuss in detail each part of instrumentation of IR spectroscopy. Thank you.